It is time to announce our second keynote speaker. Milena is an assistant professor in quantitative methodology at the Department of Methodology. And I'm not sure how to say this differently, but she's a rock star researcher within the computational social science field. Milena completed her PhD in sociology at Cornell University in 2015, and then worked as a postdoctoral researcher at the University of Oxford, and then at the Oxford Internet Institute. And she's also a graduate of Santa Fe Institute, which is a leading place for the study of complexity science and social science.
And besides her exceptional scholarly work, Milena also wrote for New York Times, appeared in media outlets such as Science, Guardian, Financial Times, BBC, TechCrunch, you named it. And she was also importantly keynote speaker in the IC2S2 2017, which was the 2017 International Conference on Computational Social Science. And it's basically the most prestigious conference in the field of computational social science. And that was really 2 years after her PhD, which just gives you the idea of the quality of her work.
And Milena's research is primarily in the fields of computational and experimental social science, and uses online experiments, agent-based models, and network analysis. And we approached Milena about 8 to 9 months ago regarding giving a LAK keynote, and luckily she accepted. Interestingly, her initial comment was that she sees a lot of overlap between her work and learning analytics. And her work primarily revolves around the study of how groups work. And the focus of her work is the study of human cooperation, collaboration, equality, and also, highly timely, contagion. And yes, we cannot avoid mentioning COVID pandemic, and so I think you got used to this until this point, that this is a common theme at the moment.
Now, what's very interesting that she uses computational games and computational experiment to study basic processes of collaboration, equality, and I can really think that we all agree how they fit into what we are trying to do in learning analytics. And there are a very large number of highly sophisticated techniques for modeling social phenomena, and Milena is really one of the best people in the world to teach us about them. The title of Milena's talk is Group Learning Analytics, and we are really enormously lucky to have someone so knowledgeable in the computational techniques to talk to us today. So please join me in welcoming Milena. Milena, the floor is yours.
Thank you so much. Let me just share my screen so we can get started. Thank you so much for the invitation. This is a great honor. Thank you so much for the very kind introduction. I am much more humble than this, but I will ride on this wave at least for the next hour. So today I'm going to talk about group learning analytics. As it was mentioned, I'm from outside of the field. So my work is not necessarily on learning, but I did try to find a lot of parallels. And I hope that I'll manage to convince you that some of the work I'm going to talk about and some of the issues could be at least inspiring or useful for you and could open some new ideas about research and collaboration. So let me just start with a bit of a background. Very simplistically, we can think about two approaches to learning or to the social world, if you wish. I'm sure a lot of you focus on individuals, so a lot of you are looking at independent learners and looking at their cognitive abilities, looking at their efforts, looking at their performance, and then you could make somehow, you can aggregate all of this and make conclusions about, say, the group, the course, or say, the platform, and so on. Now, another approach would be to look at the whole course as one single group and focus on the interactions and the interdependencies of all the individuals. So this is an approach that complex systems scientists take, a lot of sociologists take too, and this is the approach that I'm going to talk about right now. So how do we do research on learning in groups or social processes in groups? So one approach would be to start from the group and look at group effect. So basically, how does the group affect individuals? We can think about here about interaction structure. We can talk about any form of strategic interdependencies or any kind of behavioral constraints that the rules of the game, that basically the way the group is set up, could impose on individuals. And so the goal is to come from the group level to the individual level. Now, another kind of way to approach this is to start from the individuals and look up at emergent phenomena, emergent group phenomena that come up from individual actions. So here we're not talking about things such as, say, average performance, but we're talking about phenomena that cannot be just produced from the averaging individual preference or individual actions, but phenomena that are emergent. So for example, collective action is one of these phenomena. So we can think of a protest. It's not about how many people are angry. Taking a poll of how many people are angry, the government would not produce collective action, right? You need these people to come together and to do something that each of them individually could not produce. So of course, from top down or bottom up, there is also another way to look at this, is to look at the whole process, the whole loop, the whole feedback loop. And so this is challenging, but this is another aspect of group thinking about groups that you need to consider. So somehow the group outcomes affect behavior, and the behavior changes in a way that reinforces the group state, the state of the group. And this would affect behavior, and you get this reinforcement loops. So, of course, this kind of research poses certain challenges. So in my talk, I'm going to focus on 3 different challenges. They, of course, this is not an exhaustive list in any way, but these are some of the issues I've been struggling with in my work. And I'm going to give you examples of how I have approached this in my work. Again, these are not exclusive solutions to any of these challenges, but hopefully we'll get the conversation started, and it will also produce some interesting, exciting ideas, if not for future research, at least for discussion. Start with the first challenge, which might be obvious, but also could be maybe puzzling. So this is the challenge of needing more data if you do group analysis. So if we focus on individuals, we will, for example, have on the left-hand side 28 individuals. But if we look at this grouping as one, right, we have an n equals 1. So we have one observation. And so this kind of poses this challenge that we need more data when we look at groups. Now, of course, we live in the age of big data, and there is a lot of available data out there, but sometimes it's quite a challenge to find something that we define as a group, right? We know that we are part of all these interacting, overlapping networks, professional network, personal friendships, family networks, and it's very hard to define of where one group starts and when another one begins. So how can we solve this problem? Now, I will propose one, and again, this is not solving all kinds of issues with a lot of data, but it's somewhat related to what I've been working on. And this is this idea of crowdsourcing data collection. So how can we actually kind of crowdsource, or outsource the effort of collecting research data? So I will talk about research with lesson plans. So this is a project that unfortunately I never had the time and the energy to extend, but I think it's very promising. And then I'll also mention about citizen science. That's something that I'm currently working with. So let me start with one example of crowdsourcing data collection. So this is a study I did with colleagues from Sweden. And we developed this lesson plan to present to students, high school students in Swedish schools, and we named it Interactive Demonstration Mathematical Modeling. So that's all the students knew. When we entered the classroom, we gave them a tablet and we projected on the screen a game that they were participating, they're playing right now. And the game was such that each of them had an avatar, and they had the avatar had a number just to identify, they knew who they are, and it had a color. And their control, so that was the tablet, they could move the avatar in different directions, and they could also see their score. So in this case, this particular individual has a score of 5, and the score depends on the number of neighbors who have a similar color to them, and they could, and they see from this score that the way to maximize their points is if they have between 50 and 59% of neighbors with similar color to them. So this is a kind of a reenactment of one of the interactions, the real interactions in the classroom. So students were moving their avatar, they had the rules of the game, and the goal was to maximize their score, as in most games that we play. So I'm not going to play all of it, but you can see kind of the dynamics. So they had 2 minutes to do this. So now more importantly, they didn't know what this is about. But we used this so they played the game in the beginning, and then we used the results from the game to tell them about segregation. So some of you might recognize this. This is a game based on the Schelling model of segregation. Thomas Schelling is an economist who got the Nobel Peace Prize. And this is one of the kind of the most fundamental models in kind of complex systems in similar agent-based modeling, kind of the 101 in agent-based modeling, for example. So we were showing them, we used the results from the very game they played to show them what happens, how they started the game, and then how they ended up. We linked this to, with a lesson, we linked this to the Schelling model of segregation. But more importantly too, at the beginning, before they started even playing the game, we did a very brief survey. In this case, this is one of the questions where we ask them about their gender. And so this allowed us to even show in their own classroom where they are now, we allowed them to, we showed them what's the seating, what's the segregation in the classroom they are in. So in this case, actually, they're relatively well integrated. They have, each individual has about only 46% similar, which is almost perfect integration. But of course, this kind of data would also allow us to do research, right? So we recorded where they were sitting, and we knew who their neighbors were in terms of seating. And so this is the 20 classrooms we physically went to, and we could study segregation in terms of, say, gender and other aspects. We also collected data on who their friends are. So when they started the game, they logged in with their name, and then they were asked to tick on their friends and those who they seek advice from regarding their homework. And so we could overlay this and to study kind of the overlap of this friendship versus homework advice versus seating arrangement networks. So this was, again, of course, if you link this to, say, to school characteristics or to, say, sociodemographic characteristics of the area where they live in, you could start doing quite interesting research. Now, in this particular example, we were physically going from place to place, and so it didn't scale up much more, but our kind of dream was that never, unfortunately, got into to get fulfilled yet. The idea was to kind of scale this up into a lesson plan that teachers could follow, and they could teach their students about segregation or computer modeling, mathematical modeling of social processes, doing social research even, and then we could collect data that way. So that is something that we are attempting to do now. So currently we're working on another project where we are collaborating with a citizen science platform. So it's called Science at Home, and it is based in Aarhus University in Denmark. And they have developed a game for us called Urbanizer. So in this game, you are a real estate developer. You are given a block. So for example, that's you. And you're given certain resources every period, and you can invest these resources in yourself, or you can invest them in someone else. if you invest them in someone else, in another player, this player actually benefits more than what you get. So in a sense, there is a kind of a benefit from cooperating and establishing these kind of cooperative relationships with others. And so in this particular instance, we were manipulating whether you see the score of others. So in this case, you don't, you only see your own score, and whether you see the endowments of others. So you can see that in this case you can, and they are different individuals have different endowments. And so if you play this game, you get a dynamic network. And in this case, I'm showing how this network develops over time. The nodes of the color of the nodes shows the endowment level. So red is the most endowed individuals, yellow are the least endowed individuals, and the size of the node shows their score, so basically their wealth. And the goal of our study was to look at the emergence of inequality, right? We also try and we're hoping to scale this up of where we are again developing this idea of a lesson plan. We did already a pilot study with something with mixed success, but also with a lot of things to learn from. But the idea is to give teachers the lesson plan where we would not tell them what this is about necessarily. This is a cooperation game, and they could use this to first get students to participate in a research project, teach them about how do we do social science, teach them about the topic, so cooperation in networks, and then also help us collect data. And again, once again, if you can imagine this scaling up massively and also linking it to other data, for example, the socioeconomic data about socio-demographic data about students in this particular school, you can imagine that we could actually start doing quite interesting kind of research about, say, how students cooperate, how this, depending on how they're doing in school, for example, depending on different aspects of their learning environment. So, so this is kind of, again, some of these ideas that we are working on currently that relate to the problem of how do we collect so much data when we are doing research on groups. Now, another issue related to doing research in groups is the problem with data heterogeneity. So now we're dealing with groups, and it is hard to, these groups vary in size, they vary in composition, and some of this is also driven by the fact that individuals can self-select into these groups. So it's very hard to compare one group to another if we don't have control on who is in that group. So of course, one of the best solutions is to just do random assignments, right? So if you have an online learning platform, you could hopefully have the ability to, say, randomly assign individuals into different versions of the course and then compare these two different groups. And you can study actually group processes in this case. Of course, that's not always available. So, so what one can do is find other ways. So I'm going to talk about one approach we did. So this involves multi-level matching. So this matching is a technique from causal inference where you're trying to find kind of very similar cases that only differ on the treatment and the control. So it's kind of like a pseudo-experimental approach. So in this project, we used data from Topcoder, which is an online crowdsourcing platform that posts computer programming contests for volunteers, so for the users to participate in. Now, some of them are paid, so you'll compete for a prize. Others, they just, the Topcoder just posts to maintain a community, to challenge their participants, and they gain to improve, so that they can improve their reputation score. And participants often use their Topcoder reputation score to get jobs outside, real paid jobs. So on Topcoder, you submit in certain kind of contests, you can submit solutions to the problem that you've been posed repeatedly, and you get feedback for these solutions. So you're scored, you get a provisional score, and that helps you improve your score. Now, there are roughly two different ways to get this, to provide this feedback. One is when the feedback is kind of based on so the scoring is based on an absolute scale. So, right, there's some kind of optimal solution, and they're giving you kind of the percentage to which, or the extent to which you have reached that optimal solution. The other, certain other challenges or contests that are posted on Topcoder have different scoring schemes, so it's based on relative scoring. So in this case, your score depends on how others perform, or how others' solutions, how your solution compares to others. And so here we were interested in the effect of social comparison on performance, on individual outcomes. Now, in the context of learning, this does have certain parallels. So you can here think about where does social comparison come in education. So one strategy one kind of aspect in which it comes in is ranking, maintaining class ranks. This is very common in United States high schools, for example. So that's a way to kind of rank high school students, and these are used for admissions. Another way in which social comparison comes in is when you grade on a curve, right? So that's when you kind of you try to maintain a normal distribution of all the performance, and you could imagine that your score kind of depends on, say, on the best performer or the average performer or the worst performer too. And of course, there is also a tendency in learning to employ gamification and kind of employ different kinds of rankings and contests and badges and competitions to instigate learning. Now, what we know from previous research from other contexts is that social comparison drives competition, and competition is good in some cases. Competition increases individual effort and performance. So competition is actually pretty good, for example, for innovation, because you only care about this, the best performer, right? For this 1 billion person who would be motivated to come up with a cure to coronavirus. But in education settings, it's hard to argue that this is what we as educators, me as an educator, is trying to achieve. I'm particularly more interested in the distribution of performance and distribution of effort. I want to make sure that kind of my distribution is compressed as possible, ideally, right? So everybody, regardless of what skills they come in with, that they learn at a good rate, and everybody at the end is achieved kind of the best possible outcome. So, so in a sense, this becomes a question of inequality. And anytime you look at distribution, this affects kind of how are outcomes distributed in the group. So this is what we decided to look in this case. And we used this strategy, as I mentioned, we call multi-level matching, or some form of it. And so the way it worked was that we started with these contests, or challenges as they call them, on Topcoder. And as I mentioned, we separated them in absolute, those that use absolute scoring and those that use relative scoring. The ones with relative scorings are the ones that have social comparison embedded in the kind of the feedback that you get. And what we did is that we looked at how these differ, and we tried to match them. So we used the coarse and exact matching technique, which basically we try to get contests that are almost identical in a lot of their characteristics, but the only thing that they differ in is whether they employed absolute scoring or relative scoring. So you could think of this kind of as an experiment where you only kind of manipulate one of the aspects that you're interested in. This gave us this strata, right? Like, so they kind of these kind of types of contests, and then within each of these stratum, we now identified individuals who have participated at least once in each type of scoring. So in a sense, they were exposed at least once to the control and at least once to the treatment. So this is equivalent to what is known in health studies as crossover experimental design. So these are individuals, so a lot of times used in studies where you expose the individual both to, say, different treatments, and they kind of measure their outcomes after each and see how they're doing, which one is the most effective one. So this kind of largely reduced the amount of data we got, but it provided us with very kind of almost like an experimental type of setup. And in the end, for each of these individuals, we now looked at the code submissions that they did, and we used that to measure their effort and their performance. So for effort, we looked at how many code lines they have done. So we literally looked at between submissions, how much code they changed, and then summed it all up over all the submissions. And then for performance, we looked at the code itself, and we used the measure from computer science known as cyclomatic complexity that measures, in a sense, kind of how sophisticated your code is. So the idea is like higher cyclomatic complexity would mean better, kind of higher performance. So we looked at the group outcomes. So now we ended up actually with only 52 of these matched challenges. So only 52 groups, but this allowed us to compare them in terms of the inequality. So we looked at the dispersion of performance. So we looked at the code complexity and how dispersed it is in the group. We looked at how predictable performance is. So given your previous experience and previous performance, how predictable is how would you do now, right? How correlated is your previous performance to your current performance? And then we looked at how dispersed effort is. And actually in the group level, there weren't very strong results. And part of it has to do with the fact that we cannot really preclude self-selection here, right? So we could not be accounting for something in these challenges characteristic that drives certain kind of individuals to select into one of them more than the other one. And the other thing we don't account in this case is the fact that we can have heterogeneous effects actually, right? So we could have social comparison have different kinds of effects on different kinds of people. And so interacting this with what kinds of people get in, you might not get any effect, or you might get a kind of a strong effect that is not really pointing to the true situation. So what we did now is that we looked at exactly these individuals that we matched. The previous analysis was done for everyone in the group. Now we looked at each of these individuals we matched, and we're basically looking at the same individual, and we're looking at how they behave in a contest that use absolute scoring and in a contest that use social comparison or relative scoring. So this will be the pink one. And so what we saw is that when we have social comparison, we have this kind of very different heterogeneous effects on individuals depending on how good they are. So basically on their existing ability. So what we see is that those of lower ability, so the bottom performers decrease effort, while the top performers increase effort. And so in the end, you get this actually more extreme distribution of performance, so more dispersion of performance. So you can see this by the slope when we have social comparison. And this is largely driven by the top performers. So competition, social comparison is great for those who are already good at it, but it's actually pretty bad for those at the bottom. And if you want to use something like that in learning, it's obviously not really helping these individuals. So in a sense, social comparison kind of reinforces pre-existing differences, even makes them worse, and does not engage those that are that have more to gain actually from it. It reinforces the status quo in a sense. Okay, so this was about regarding and how do we deal with heterogeneity and the fact that we have individuals self-selecting into groups, and especially if you have to observe this group not in an artificial kind of environment, experimental setting, or in a field experiment, which are not that easy to do. And but what if you have observational data? How can you deal with this? Now, the last challenge I'm going to talk about, and this is kind of the most fundamental challenge here, is the fact that anytime we look at groups or networks, we are dealing with non-independent observations by definition, right? If when we do random sampling from the population, we can isolate the individual from anyone else. But when we look at a group, by definition, everyone's connected to everyone. You get this kind of chain link fence mesh of interaction. It's very hard to isolate an individual from their connections, from sources of influences around them. So here I'm going to talk about another study that we very recently finished. So this is a study in which we employed one method from social network analysis. Of course, social network analysis is or network analysis in general, right? They are particularly concerned about how do we deal with non-independent observations. We use temporal motive analysis to deal with enormous amounts of data. And these data come from a game, online multiplayer game known as PlayerUnknown's Battlegrounds. So it's also known as PUBG. And it's a first shooter game in which teams of, so we call them matches. So in a match of up to 100 individuals, random individuals are usually matched, and they're dropped on a field, and they're supposed to kind of kill each other and scavenge around. And the goal is to be the last one surviving. And the field starts compressing so that players are kind of forced to interact with each other, so you don't just like hide and do nothing. So the game is more interesting, basically. Now, in this game, something that occurs in actually in a lot of online first person shooter games is that there is actually a lot of cheating. So cheating in this case involves obtaining software. So this is software that's not approved by the gaming company that allows you to do things that the game wouldn't normally do, and this gives you an advantage, unfair advantage to others, right? And also at the same time, it obviously kind of makes the experience of others less exciting. So in this case, for example, this software would involve, say, a wall hack, which would mean that you can see through the wall, and so obviously no one can hide behind it, so you can kill someone even behind the wall, or an automatic aim, for example, the aimbot that you can it automatically kills anyone who's inside. So we wanted to study the social contagion of cheating and on this particular game. And of course, this is a kind of an example of social contagion of antisocial behavior in general. So antisocial behavior would be any kind of behavior in which we gain a benefit, but others suffer, right? And often it might involve actually kind of directed behavior. So for example, we can steal from someone, and right, so that kind of there's one individual affected. In other cases, it's more diffuse, such as, for example, tax avoidance, right? Maybe the benefits are not necessarily direct. But in the context of learning, we can think here about academic cheating, so plagiarism, or bullying, for example, in educational environments. That could be also another kind of aspect. You can also think of trolling on online forums, abusive language online. So these are all kind of antisocial behaviors that may make you feel good of doing it or give you benefit, but they affect others negatively. And they also have the potential to spread. And we know very well that, for example, trolling could be contagious, and you would have whole forums just shut down because of the spread of trolling. So now, previous research that I did, actually in my dissertation, my PhD dissertation, is that we distinguish between two mechanisms through which antisocial behavior, or pro-social behavior too, could spread. So in the case of antisocial behavior, we can think of spreading through victimization. So the mechanism is generalized reciprocity. And this idea is that if someone, say, is mean to me, then I might not be able to pay it back, but I can pay it forward. So you can think here, if the boss at work is angry with you, yells at you, then you go home and you yell at your children, right? So in a sense, it affects your affect. It makes you feel bad about this, and then it kind of trickles down. The other mechanism, so this is victimization. The other process through which we can have social contagion would be through observation. So in this case, I observe somebody behaving badly towards someone else, and I do the same to a completely third person. So this is kind of a situation in which it's more about kind of normative influence and also informational influence, right? This kind of idea is like, oh, this is acceptable, others do this, nobody gets punished, well, I might as well also do it, right? So there's also kind of sometimes even peer pressure in some cases that, oh, that's what you're supposed to do here. So what we set out to do is to try to differentiate between two mechanisms in the data we had. And so in this case, we have a network of who kills whom. So this is this image to the left of where we have about 100 nodes, and the black or the pink lines show the network of killings. So who killed whom. The darker the lines, the thicker the lines are, it means that the event happened later in the game. And so pink in this case means that we have a cheater. So here we have 3 cheaters. This is quite unusual for a game. Usually in this game we had fewer, a very small percentage, I think it was less than 1% of cheaters from all players. But nevertheless it occurs. And we also created a network of who observes whom. Now, in the game, there is no tag of who is a cheater, right? I mean, if there was a tag, then the game company bans these individuals. So, and that's how we actually understood who was cheating once their accounts got banned. But we assumed that a player would observe another player and consider them a cheater if they have at least observed 5 consecutive killings, so that they have had enough kind of observations to see any abnormal patterns of killing. So as I mentioned before, it's the whole point of cheating in this game is that you get these tools that help you to give you superpowers in a sense. And so this might become obvious to other players. And in fact, a lot of players kind of report on each other. And there are also certain tools in the game where you could rewatch the game from another player's view so that you could confirm this. So what we did in this game is that we tried to look at, to identify temporal network motifs in the game. So these are kind of sub-networks, so there are small patterns in the network. And in our case, we were interested in a situation in which a node or a player I either observes a certain number of cheaters or is killed by a certain number of cheaters. And then in consequence, within time delta, so in our case, we took a time delta for 1 week because there's kind of a natural, weekend peak for playing the game, they start cheating, right? So during that period, we assume that there's kind of this effect trails off after a while. So if they haven't started cheating within a week, then there is no strong effect. So of course, we can take these motifs and we can produce a count. We can look throughout the network. So by the way, our network was about 1 million matches of 100 players overall, of 2 million players, and the number of killings were about 98 million killings, right? So enormous network. You start counting these motifs and you get some number. Now the question is, well, so what, right? Is it possible that this is largely driven by the fact of, just how the network looks, right? Because in our case, you can see that there is a very peculiar structure to this network, driven by the fact that if you can only get killed once, if you're killed, you cannot observe, and so on, right? So there are the kind of very peculiar rules of interaction that drive the network. So perhaps this number that we get, this number of counts, is driven by this, and it's in no way abnormal. So usually what you do in cases like that is that you want to create a null model that basically gives you the baseline, so gives you an idea of what would occur if we randomize the sequence of events. In our case, would we still observe this number of patterns? So what we did in our case is that we wanted to preserve as much as possible from the kind of the nature of interactions, the structure of interactions, but we wanted to shuffle, kind of randomize this who gets killed by whom in a sense, right? So would I have started cheated if I was not killed by a cheater in that game? And so what we did is that we kept cheaters without randomizing them, because cheaters tend to kill more. That's the whole point of getting these tools. But we shuffled the other individuals we just kind of change their node labels. Now, in some games, actually, we have teams, so you can have teams of up to 4 individuals who would play. And in this case, you could potentially have homophily, right? So you could have the same individuals playing, selecting, I mean, so basically this kind of certain individuals who might be more prone to cheating, selecting each other. And of course, this would affect the chances of them observing or getting killed by a cheater, because teammates don't kill each other. And also they're more likely to observe each other. So we only shuffled within teams. Basically, that's what we did. And so again, we're trying to preserve the structure. We're trying to kind of abstract from homophily and any other forms of influence. We're only interested in what happens if we randomize the sequence of events. What if I was not killed by a cheater? Would I still cheat? And so this gives us certain, we can do this multiple times. And this gives us a kind of a distribution of expected outcomes. And now we can see where our empirical count in the network stands in this distribution. And so that's what we show here. This basically gives us the percentage or the proportion of the randomizations that were producing a motive count that is as large or larger than the one we observe in the network. And so what this tells us is that there is some evidence for the social contagion of cheating, but this cheating is contagious only for individuals who both experience and observe, right? So we don't have evidence for any of these. And when we unpack this, in this case, we kind of count every single event, regardless of whether they concern the same individual. Now here we are counting basically individuals that have, for example, observed exactly 3 cheaters and being killed by exactly 1 cheater, right? So now we're controlling for the fact that we only dealing with individuals, and this will tell us, is this effect driven by, say, a large number of individuals with weak effects, or is it driven by a few individuals who have just observed and experienced a lot, and this is what has driven them to cheat? And so we see that indeed, actually, there is kind of a strong evidence that there is a bit of what is known as complex contagion, this idea that the more you observe and the more you experience, you suffer from cheating, the more likely you are to become a cheater. So in summary, what we try to see is that, to show is that those who both suffer from and observe cheating, and particularly when they experience and observe it multiple times, they're more likely to start cheating. And of course, this has certain consequences, certain kind of implications. So for example, one of these is that if you want to stem contagion, to stop contagion, you want to minimize the personal cost of other social behavior. So just observing is not enough, but once you suffer, this might be something that might trigger you. So if you want to go back to kind of our example of, say, grading on the curve, now grading on the curve is a situation in which your performance affects my performance, right? So so your mark could affect what mark I get. And so if you cheat, you directly affect me, which is much less the case if you have some kind of absolute scale of performance. So this kind of research would suggest that we would have, for example, more contagion of cheating, so more spread of cheating in groups that employ basically grading on the curve than groups that don't, right? So this is, again, kind of a macro level hypothesis based on this study, and that you could potentially test in a learning environment. Of course, it's hard to kind of obtain the level of detailed data that we got from this game, but it still gives us insights for other environments. So, so just again, to kind of summarize and reiterate some of the points I've been trying to bring to you with these 3 different examples I was giving, and hopefully these are some of the ideas that you kind of took away from this research, is that there is actually, we can get some very interesting insights from focusing on groups in the context of learning or in social contexts in general. And if you're interested in doing research in this area, I think the kind of the ultimate kind of goal is to focus, to look for situations where you have non-independence. So one way to do this is to focus on social interaction and how the structure of social interaction affects individuals, right? So we can think here about the structure of interaction. We can look at the composition of groups. We can also look at how fixed these groups are, right? So for example, team assignment, is it fixed or are these rotating teams? So, and this could, right, like you could expect different kinds of behavior of individuals depending on the group they interact with, the rules of the game. Another kind of way to do research on learning in groups would be to look at emergent group level phenomena. So I think some of you might have experienced this, where you would be teaching the same course and you know, 1 year it's great, everybody loves you. In another year, it's suddenly right, like something just went wrong, and you know, the student evaluations are just abysmal, right? And obviously, I mean, to me, it's obvious like that there is some kind of self-reinforcement in the group, and some kind of like emergent, you know, social contagion of where, you know, somebody managed to say, or a group of individuals managed to shift the discourse, and now everybody, you know, hates discourse. Of course, not to this extreme, but it's always interesting to observe these kind of cohort differences. And a lot of this has to do with, you know, this kind of emergent group level phenomena. So, and of course, a lot of it is driven by these feedback loops, the possibility of feedback loops. And these could be because of individuals talking to each other. So you knowing about others, what they think, right? This could kind of change your own behavior and your own opinion. Also, of course, there are situations in which you can think about incentives. So it's not only about the information, but actually it's about how others affect my outcomes. And so here, more directly, we can think about ranking, contests, or any form of gamification where it's, if there is any time there is a social comparison, there's information about others, my performance depends on others' performance. So there are certain incentives that are linked to others. And finally, anything that has to do with contagion, peer effect, social learning, imitation, echo chambers, any time when we kind of, we hear from others and we are connected, which is, one could argue, quite always the case, that's when we have the potential for a feedback loop and having a kind of drastically different emergent outcomes depending on the rules of the game, depending on the structure of interactions. Now, I mentioned about methodological challenges, and here is kind of a summary of those. Now, I talked about gathering more data, reducing the data heterogeneity within the group, which could be challenging, and then analyzing non-independent observations. So for gathering more data, I talked about how we can potentially crowdsource data collection, kind of embed it in actually the education plan. I think that's actually quite exciting of how you could get like social scientists and educators to work together and mutually benefit each other. But I think there are also other kind of ways to do this. In my own work, I have, for example, in the past have done a meta reanalysis of existing data. I think at this point, actually, we are so deluged with data and it's not even that kind of difficult to obtain data, especially if you just scrape things or just digitally record others' interactions. But at some point, I think that there could be insights in how do we we could combine, if you're looking at groups, we could potentially combine different kind of distributed attempts to collect data and find interesting connections between these different studies. And also look at kind of in the data in different ways. So not just meta-analysis, but actually reanalysis, where you look for a new dependent variable in a sense, using all these efforts that have been done. Also regarding reducing data heterogeneity, of course, random assignment through experiments is also always the gold standard. I talked about multi-level matching, but I think another approach would be to focus on actually group heterogeneity as the dependent variable. So instead of looking at it as a kind of a nuisance that you have to get rid of, as a if you want to focus on a group and group outcomes, it actually might be, this could be the interesting part, like why do some people drop out of this particular instance of this course more than this other instance of the course, right? So, or why does it attract certain kind of individuals more than others? And finally, of course, regarding non-independent observations, we have multi-level models, and we also have, in addition to temporal network analysis, we also have actually a good suite already of statistical models for networks, for statistical inference on networks. So exponential random graph models are some of those, and stochastic actor-oriented models, and these have been used widely in the realm of learning. So so I'd like to thank you for your attention, and I'd like to also thank my collaborators for all this research, and one of the funders for part of this research. And I also want to kind of extend to you an offer for any of you who would like to take this further, please feel free to contact me and we can meet one-on-one. I actually was kind of very disappointed that I wasn't able to attend in person. But since for me this is a new world, and it would have been very exciting to talk to a lot of you just kind of serendipitously, and to come up with some new ideas and new connections. But we can take this one-on-one for the future. So please feel free to contact me. Thank you.
Applause, applause from my side. I can see people writing applause, applause in the chat, and I guess you can see that too now that you stopped sharing your screen. Thank you very much for this keynote. That's some really fascinating results, and I'm sure there are some questions that people have. I could see that some people were already writing and discussing in the chat. So is there anyone who wants to ask a question? Please raise your hand. I can give you audio so you can ask your question directly yourself. And I will see if there was some questions atop the applause that I was seeing. I could see there was something, I think Yishan wrote something at some point that I could see. Okay, attendee, someone is raising their hand. Okay, Peter, I'm giving you.
Thank you. Here's Peter Brusilovsky. Thank you for a very nice talk. So the results you presented on social comparison is something which people always argue. It's nice to see it documented. So that means rich are getting richer. Active people get more active, and passive people get more passive. Surprisingly, in our studies, we get don't get these results. And I'm trying to figure out what is your experience with studies similar to yours. It is always like that, really, that active getting better and passive getting worse, or there are some situations where in fact it doesn't work. So maybe we're just in this kind of dark corner like that, other dark corners where this rule doesn't really work.
Yeah, thank you so much for this question. So I must say that again, I'm not I'm not familiar with exactly what realm your study is in, and of course the context we look at this is very peculiar in a certain sense, right? Like, so it's a kind of a specific kind of interaction, specific kind of contributions and work, so might not transfer to other contexts. And I'm particularly, I mean, for us, I thought that like actually this was kind of one of the innovations of our study, was to look at a new dependent variable, in a sense, to look at the spread of outcomes, because actually there's a lot of literature, a large amount of literature on social comparison, particularly incentives, so monetary incentives. So if you think about this as a kind of the comparison between the contests and price contests versus a piece rate scheme. So whether you paid per output, or whether you are paid, like only the winners are paid a certain price. And so there is a lot of research from management and from behavioral economics about this, but the focus has always been on how does this affect the best, the best contribution? How does it affect the average contribution? And so we were focusing exactly on kind of a completely different story of being, okay, in some situations, maybe that's what you care, especially if you want to extract value from others. But in other situations, you're more interested in the distribution. How does it affect the distribution of outcomes? So I'm not familiar with much research that has focused on this, and I'll be actually very interested. I will be happy if you can directly send me the study that you mentioned, because we still haven't published this yet, and we're still revising it now, and so I would be happy to include references to larger literature that looks at this and maybe finds contradictory results.
Thank you.
Great, thank you. Then before I give the voice to Sebastian, who also raised his hand, I have one question from the chat, and that is Mohammed Isayuya, and he asks, I'm just wondering how we can leverage the results of such social studies to design better technologies. In other words, what social factors can we leverage in the design of learning analytics technologies, and how can we leverage them?
Ooh, that's a big question. Okay, so I mean, if this, so obviously, I mean, I think that my research is mainly focused on kind of fundamental social processes that have some relevance to learning, but then obviously also could be processes that occur in other systems. And I think that there is a lot to be learned from this, right? As I'm sure we all are doing this, and a lot of technology is doing. So social psychology, cognitive psychology, right? A lot of kind of the technologies are based on basic social science, right? Like our understanding of how individuals interact or not. I'm particularly keen on kind of the project of where we were trying to embed, in a sense, learning technology with doing research, right? Like social scientists doing research with the learning technology. And that's I think that's kind of a promising avenue of where we could, in a sense, use the same event to both teach students about doing research or about the subject matter, but then also to actually use their interactions to learn something about them, right? So this kind of possibility of doing these interactive demonstrations or games in the classroom where we could collect data about them and how they interact, but then also use, and in a sense, almost feed it back to like teach them something about themselves or about others in the classroom.
Mm-hmm. Thank you. Then I have one more question from Oheja Padrik Ilianova. Sorry if I bungled those names, sorry. And he asked, she asked, in the experiment on pure facts, are there any evidence that players who were not killed by cheaters learned to play differently and better? It will be interesting to know if this changes depending on the motivation or distance to the end goal.
Yeah, so the data we have is kind of very right. It's only based on, it's only the events of killing, right? So we don't have much more data regarding kind of different strategies or anything like that. So we will have to do actually quite a lot of machine learning to kind of try to identify from behavior and from the patterns of changes in strategy or anything like that. But it is not impossible, right? So it could be quite an interesting situation. I mean, one thing to know is that, I mean, there might be a lot of players who are blissfully ignorant of the whole cheating problem. And so they are likely, right, like it doesn't affect them in a sense, because if they never experienced it or they never observed it, they will never realize that this is something to actually that occurs.
Mm-hmm. Okay, then I have one last comment / question from Yishan Zain. She asks, I'm interested in the connection between contagious cheating and self-regulated learning. I think the perceived benefit to reach a desired goal quickly is the main motivation for people to copy the cheating behavior. So could we use this observed phenomenon in some way to observe learner motivation and the influence of this motivation on a change of learning strategies and the positive impact of social interaction on this? That would be interesting.
Okay, I am not familiar with self-regulated learning. That's probably would have been something that I would have learned had I attended this conference in person. So I'm sure some of you might have more insights on this very interesting comment than I do.
Then we have another comment or question here in the chat, and Henrique Chevreux asks, have you researched the impact of anonymity versus publicity as well?
Regarding which study, I wonder? Anyone? Not really. A lot of the experiments we do, everyone is anonymous, in the sense that we control the information that that they have about others, right? So we very precisely assign numbers to them, or we assign location on the board or anything like that. We only produce the information we basically we want to reveal. Now for example, in the top coder study, that's not the case. So they are so obviously participants, so users of the platform might know each other. They also have reputation scores, and then it is possible that they they kind of they react differently depending on, for example, who is on top, who's doing better than they are, or anything like that. So in this case, we have much less control in that case.
Mm-hmm. So Enrique, he added, because of the effect of reputation and respect or / authority of some players or authors of actions.
Yeah, no. So obviously, I think that that's something to definitely keep in mind. And again, it's usually by default all experiments are anonymous, and by default in real world that's hard to achieve, right? And so it is possible. I mean, so the thing for the game, particularly for the PUBG game, matching to so how you enter a match is actually random assignment unless you have selected your teammates. So in this case, we're talking about 2 million players. So the chance of you being matched with somebody is pretty small unless you have selected them. So I think in this case, we almost have like a close to kind of anonymous situation, even though we have a real world observational data.
Okay, he says, understood, thank you very much. Are there any other questions? I think we have time for like one more question. Anyone wants the audio or wants to write in the chat? There's 112 people in the audience, so any one of you can now use the chance and raise your hand and ask Milena a question. Or give a comment, or maybe someone on the panel. Does any one of you have a question?
I have several questions, and thank you, Milena, for a great talk. One, I was thinking about your point on running in this particular game. So basically, a massive number of repetitions of a single, kind of interactions, and then looking for patterns. What would be interesting in education is that often things change over time. And for example, if we have a certain learning activity, say if we want to see how the structure of a group assignment will affect their interaction in the groups, how will affect their performance, something like that. The problem is, if we ever try to pick, say, 20 years of the data we have, course changed 15 times in those 20 years. And then, instructors change, or something is added, the group is now it's not mandatory, now it's required, now it's not, and it's extremely messy. And I really appreciate the fact that the study of things, like your study, those fundamental things are very in cleaner, at least cleaner state and cleaner environments than what we do. And that's, I think, the main challenge is for me, for example, if I'm trying like, okay, this is a great idea, how would I use that in one of my studies, is in the historical data over time changes so drastically.
No, I agree, and I think that's why maybe the solution is if you cannot do random assignment, right, like a random kind of intentional changes. I think that because, like, for example, for the top coder study that we had, I think what saved us was the fact that we actually had, well, okay, sure, we had one system, but the fact that we had so many instances of contests that we could find a way to find similar comparable contests, right? And so I think that's why maybe for the future there could be a possibility of where if we could combine data from actually different sources, we could, surprisingly find enough similar kind of instances of, say, of a course that differ largely on kind of more significantly on the treatment we're interested in, right? And I think that's kind of the promise of big data, that as we get more data, we actually we don't have to analyze it all, but actually the key is that it allows us to select kind of cases that could be kind of more comparable than others. And then even if there is some noise, if we can do this at a large enough scale, it could provide certain kind of patterns that we can observe. But I agree, it's a challenge, and that's why it's very hard to do this with observational data. And the temptation to just, running an experiment is usually just kind of the easiest way to deal with this. And at the same time, it is quite time consuming and difficult and has all these ethical implications. And yeah, it's a completely different story. Yeah.
Okay, great, wonderful. Then one round of applause again, all of us.
Thank
for
you.
Thank you so much for giving this keynote, and please feel free to stay during our closing remarks. And you will get to see some of the some nice photos, and you will actually get to see some statistics as well. Thank you very much again.
Thank you.